Hey folks, this is Scotsman. Welcome to the Miro SDK primer on using ProBuilder in Unity to create level geometry. Open a new Unity project and install the Miro SDK. Follow the Miro SDK project setup guide for details on this. Next, once Unity is open, delete the camera. Select the Window menu, then Package Manager. Ensure that the Packages drop-down menu is set to Unity Registry. Next, search for ProBuilder in the field to the right and install it. Even though Unity finally has its own grid and can perform grid snapping well enough, the Unity grid has a few flaws that I dislike, so I prefer to use a companion package to ProBuilder called ProGrids. This step is optional if you want to use Unity's built-in grid system. However, if you prefer ProGrids, you can install it by selecting the plus drop-down menu and choose Add Package by Name. Then type com.unity.progrids and press Enter. Wait a few moments and Unity will install ProGrids. Close the Package Manager window once done. Next, under the Tools menu, open the ProBuilder window and dock it in an easily accessible location. The ProGrids overlay will likely be sitting atop the main Unity Tools overlay. Reposition one or the other so that they do not overlap. Since we're building directly in Unity and have the Miro SDK at our fingertips, we can simply add a player marker to get the proper human size scale reference. Before we start making cool stuff, we'll turn on grid snapping to prevent us from going insane. One of my gripes with the Unity Grid tool is that grid snapping is only available when the handle tool is in global mode. If you try to manipulate an object in local mode, the object will not snap to the grid as it is moved or scaled. Second, the grid visuals are monochrome, and the default color is hard to spot against similar colors. This is remedied easily enough by setting the grid to something with high contrast like magenta. However, the default grid is only visible in a single plane, and the finer increments between main units nearly disappear if you move the camera too far away from the selected object. Adjusting the grid on the fly also takes several clicks, and you'll need to type in an increment value almost every time. One of the Unity Grid's saving graces is that you can swap between grid snapping and increment snapping by holding down the Control key as you move an object. This means that you can set the visual grid to a value and objects will snap to that visual amount by default, and then hold Control to have them snap based on your increment value. This feature still doesn't outweigh the other downsides in my view. Once you get comfortable in ProBuilder, you may find the hiccups of adjusting the vanilla grid slowing you down. ProGrids uses clear, contrasting visuals for the three major axes. All three axes can be made visible if needed, and the increments of the grid snap can be quickly adjusted with the plus and minus keys, streamlining its use for your workflow. In 3D axis mode, they follow the object that you have selected by default, whereas the default Unity grid requires additional clicks every time that you want it to jump to your selection. Whatever grid solution you choose, enabling grid snapping will save you endless hours of frustration and tedium because you will not be fighting the sloppiness that comes with just eyeballing whether or not two meshes are lined up. You will know it thanks to the grid snap. Also, if you're building something indoors, there's usually an expectation that floors are level and doorways are more or less properly aligned. It's important to note that ProBuilder operations only work on ProBuilder geometry. If you create a normal Unity 3D cube, for example, you'll be unable to manipulate its faces and vertices beyond the simple scaling or moving the whole object. You can change a Unity 3D object into a ProBuilder one by selecting the non-ProBuilder object and choosing Tools, ProBuilder, Object, and ProBuilderize. There are four main workhorse operations that you will use to create most level geometry: extruding faces, creating edge loops, the face or edge drag, and the extrude and scale tool. Extruding a face in ProBuilder is done by selecting a face, holding Shift, and then dragging the selected face in the preferred direction with the mouse. Creating edge loops can be done with Alt-U, and makes clean splits in geometry. A common usage is to add doorways and hallway entrances to rooms, but edge loops can also split geometry in ways that can add detail. The face, vertex, and edge drag takes existing geometry and manipulates a face, edge, or vertex in a direction to change the object's shape. There is no dedicated inset tool in ProBuilder. Instead, holding Shift to enter extrusion mode, and then scaling down will perform an inset. This is commonly used to create a window or vent entrance in a wall. Extruding and scaling outward will grow the selected face radially. Using this operation on a cylinder and scaling the face up or down is a quick way to add detail. This short primer will only use extrude, insert edge loop, and face dragging in order to create several rooms and hallways. Begin with a 10 by 3.25 by 10 meter cuboid, 10 by 10 in the X and Z, and 3.25 meters tall. In the ProBuilder window, click New Shape, and then drag out the base dimensions along the X and Z axis. Click, and then drag up or down to add height along the Y axis. Do not worry about sizing this exactly. Since we know the numeric values for creating the cube, we can use the X, Y, and Z fields in the Create Shape overlay to adjust the shape before finalizing it. This cube will be turned into a small room into which the player can spawn by simply taking the outward edges of the cube and flipping them inward. To do this, select the object and click Flip Normals. If needed, adjust the grid scale to 0.25. We'll now add a hallway to this room using the Insert Edge loop. Swap to Edge mode, and then select a horizontal edge along the positive Z axis of the cube. Next, press Alt-U to insert an edge loop. Use the mouse to position the loop 1 meter from the center of the room. Selecting one part of the edge loop and then pressing Alt-L will select the entire edge loop. Select the longer edge along the positive Z axis and insert another edge loop. Repeat the adjustment of the second loop, but pull it 1 meter to the opposite direction from the center of the room. This will create a 2 meter wide hallway. You can switch to a top-down isometric view by clicking the positive Y-axis in the axis rows in the upper right corner of the screen. This can be very useful when verifying positions and distances. You can toggle between perspective and isometric views by clicking the label beneath the axis rows. Select a vertical edge of the cube and insert an edge loop. Position this loop 1 meter down from the ceiling. Switch to face mode. Select the positive Z face that will act as a hallway entrance. Hold Shift to extrude this face and drag it along the positive Z axis to create a 5 meter long hallway. Since each grid segment is 0.25, spanning 20 grid squares will equal 5 meters. Extrude this face again in the same direction, but this time pull it twice as far to make a 10 meter long object. Then, repeat extrudes on this object to the left, right, and upward to reshape it into a whole other room. Take care to select all of the roof faces before extruding the ceiling upward. Extrude to make another hallway in the opposite end of the original room. We're going to duplicate the room that we just created and connect it to this new hallway. But the goal is to show some problems that can arise when trying to duplicate geometry, and then cover how to fix them. Unity does support copying and pasting objects using Ctrl-C and Ctrl-V, or by pressing Ctrl-D to duplicate, but these operations only work for entire objects. To duplicate just a selection of faces, use the ProBuilder Duplicate Faces operation. From a top-down view, select the room, and then click the small plus button next to the Duplicate Faces option. This will allow you to choose between creating a whole separate game object or creating a submesh. A submesh will keep the duplicated faces as part of the current mesh, but they can be moved and adjusted as needed. The next step is to create an opening into the room by deleting the faces of both the hallway and the room. The delete key in Unity will remove the entire selected object. To delete just selected vertices, edges, or faces, use the backspace key. Now to clean up the geometry. Because this room was duplicated and both hallways and the room had vertices at the hallway entrance, there are now two sets of vertices overlapping each other where these two pieces meet. To repair this, enter Vertex mode, drag select all of the overlapping vertices, and click Weld Vertices. Since grid snapping is enabled, the vertices should be close enough to be welded together, but if not, you can click the plus button next to Weld Vertices and define the weld distance. You can verify that this operation was successful by grabbing one of the newly merged vertices and dragging it around, making sure that both the room and the hallway are reshaped. This confirms that the two pieces were connected successfully. Because the copy of this room had a hallway entrance at the opposite end, there is now a large hole in the geometry on the other side of the room. To repair this, have the object selected and enter either Vertex or Edge mode. Click Select Holes, and then Fill Holes in the ProBuilder menu. Note that Unity will fill the hole with a single face, but the original geometry had a horizontal edge loop that wrapped the entire cube. If you wanted to adjust this later, or create another doorway, the edge loop would be broken. To add the edge back and restore the structure of the cube, switch to Vertex mode. Select the two vertices that are missing their connecting edge, and then click Connect Vertices. Adding detail to geometry is one of the areas where ProBuilder can fall short of its dedicated 3D software brethren. In the Blender version of this level tutorial, the bevel tool is used to create a rounded corner. ProBuilder's bevel tool is not as sophisticated, but it can be used to make a chamfer. To demo this, create a new 1x1x1 ProBuilder cube. Select this new cube, enter Edge mode, and then select an edge of the cube. Next, perform a bevel. In ProBuilder, this will create a chamfer instead of a rounded edge. If you wanted to simulate creating a rounded corner, you would have to diligently create additional edges and chamfers, making all the segments of the curve, and then manually arrange them into a smoothly rounded corner. Since Blender is free, I would highly recommend installing it and making these sorts of finer details there. Thankfully, it's easy enough to make these few detailed bits and then import them into your map. External meshes made by Blender and the geometry created by ProBuilder work quite well together. Congratulations! You now have enough geometry creation knowledge in ProBuilder to complete the Geometry and Colliders level tutorial. See you in the void.